Today we have a short lesson on pictographs. Let's read our I can statement together. I can read and construct pictographs with large numbers. So our focus is on pictographs and large numbers. If I look at that word pictographs, and maybe I don't know what it means, or I can't remember from last year, well, I know the word graph, and the word graph it's like a picture that shows me information. And the picto tells me what kind of a graph it is. Pictograph. Picto looks like picture, and that's exactly what it is. A pictograph is a graph in pictures. Let's look at a graph about Dana and Paco. Here's a pictograph about the number of bagels, I can tell because that's the title of it, bagels, that Dana and Paco both have. If I were to look at this, I would think that Dana has 1, 2, 3 bagels, and Paco has 1, 2, 3, 4, 5 bagels. And the way this looks right now, I'm absolutely right. Dana has 3 bagels and Paco has 5 bagels. Now I want you to take a moment, and I'm going to ask you to pause the video in a second. I want you to think, what could you change on here to make it show that Dana has 30 bagels and Paco has 50? So I want you to think about what would it mean if Dana had 30 bagels and Paco had 50 bagels. What would you change? Pause the video and think about it. Okay, I'm going to come back. Hopefully you have paused the video. One thing you could do is you could make a whole bunch more bagel symbols, right? Until you get to 30 and 50. But what if I don't want to do that? I don't want to draw 30 or 50 bagels. I want to leave it just as it is. Well, what I could do is I could make a key at the bottom and say, well, that symbol no longer equals 1 bagel. Now it equals 10 bagels. So if I look at my picture now, each time I see one of those pictures, I have to count 10. So I'll count this 10, 20, 30 bagels. Dana has 30 bagels. This is my key down here. This is really, really important to keep track of when you're looking at a pictograph. Otherwise, you might still think Dana has 3 bagels, which is way, way off, because she actually has 30. Let's count for Paco. Each time I see that, I'm going to count 10 bagels. So I see 10, 20, 30, 40, 50. Yes, we got Paco to equal 50 bagels. What could you do if Dana and Paco were buying bagels for a ton of people, and Dana bought 300 and Paco bought 500? What would you do? Pause and think. Okay, I'm coming back. Hopefully you paused it. Well, the easy way to do this would be to say, well, I'm going to change this key, and no longer am I going to have the symbol equal 10 bagels. I'm going to say it equals 100 bagels. So now each time I see this symbol, I'm going to count 100 bagels. So let's see here, 100, 200, 300. Yep, Dana has 300 bagels. And Paco has 100, 200, 300, 400, 500 bagels. They must be buying for a huge crowd. Next, I'm going to give you some numbers that aren't quite so easy. What if instead of those numbers that I gave you before, what if Dana had 31 bagels and Paco had 59? What would you do? Could you make a pictograph that has exactly 31 and 59 bagels? I suppose you could, but it would take a really long time. So sometimes our pictographs are not going to equal exact amounts. They're going to show us about how many things are represented. So I would take 31 and I would round it to the nearest 10. So I look at the tens place, and the ones place is going to tell me to round up or down. Well, 30, is it closer to 30 or 40? And I can tell that it's closer to 30. 59, however, I'm rounding to the nearest 10, and the 9 tells me to round up. It's closer to 60. Remember, I could say the rhyme, 0 through 4. Is it 0 through 4? Hit the floor? Nope. 5 through 9? Yep. Climb the vine. So I would say this is 60. So my key is going to stay the same. It's going to say 10 bagels. And I'm going to represent that up above. How many would I have for each person? Well, Dana would have 10, 20, 30. And Paco, how many would Paco have? Paco would have 6, right? 10, 20, 30, 40, 50, 60. There we go. Now, does this show exactly how many they have? No, Paco had 59. But this is as close as I can get. I can't really cut this into tenths and show that that's 50 and then 9 more. And I can't really show one tiny sliver of this. So I'm going to be about. These are rounded numbers. So this is 30 and this is 60, about. Now I'm going to give you one more to think about that's a little bit different. So here's another situation that we could have a pictograph. I see that I have Dana has 35 bagels and Paco has 60. Well, Paco up here, 10, 20, 30, 40, 50, 60. Yep, that's 60. But this does not equal 35. And I don't really want to round this because it's right in between 30 and 40, and I want to represent this exactly. What could I do with this picture to show that it's 35 and not 30 or 40? Well, I know that 35 is directly between 30 and 40. So if I had a number line 30 and 40, 35 would be right in the middle. So that means it's halfway between. So if I could take my picture and cut it in half, that would represent 35, or it would represent 5, and I could add that onto there for 35. And now we can see by my picture that Dana has 10, 20, 30, and half of a picture for 35. So half pictures can be very, very useful. I'm going to have you do one more thing before this video is done. And here it is. I want you to think about these sets of numbers. So 200 and 300. What is halfway between 200 and 300? Then I want you to think about the next set, 6,000 and 7,000. What is halfway between 6,000 and 7,000? And lastly, 10,000 and 20,000. What is halfway between 10,000 and 20,000? I want you to write those on a piece of paper and be ready to explain why you think those are the answers. This will help us figure out what pictures could we draw to represent half of those numbers, or halfway between 200 and 300, 6,000 and 7,000, and 10,000 and 20,000.